Yo guys, welcome to the video, and in this C++ tutorial, in this new series, we are going to talk about pointers and what they are simply and how they are used, etc. Now we will be touching on arrays and pointers, of course, again, very basic, or this video would have been like 50 minutes or 100 and even an hour long, and we still maybe go halfway through what we need to go through, so this will keep it simple for today's video. We're going to be talking about pointers and the basics of pointers. Before understanding pointers, I think you guys should understand data types. Now, data types may sound simple to you, but you don't really know what's going on with data types if you think they're simple. An example of a data type or a couple data types would be int, maybe something like float, double, char, and bool. There's no like specific order and why they're here, but I just did them like that, like come with their IFDC, whatever that is. Oh, to be, yeah, my handwriting sounds good, so I thought it would be. And int usually, so the way a variable is even made is, of course, you have to call its data type, then the actual name of the variable, so name, and then this is optional, of course, optional, whatever this word is, maybe a value, right? C++ does allow you not to write a value for a variable in the beginning unless you're doing some sort of operation with it. So it is optional basically, but most important thing is data type and name, right? So a data type again would be an int, a float, or any of these, or even more, of course. So it allocates the way a variable is even compiled by the compiler. The way a compiler perceives a variable is the compiler says, okay, so he wants me, for example, to store, maybe he maybe wants me to allocate some memory for a variable called apple. Okay, that's interesting. Now, okay, so how much memory does he want me to allocate for it though? Does this compiler know? Well, yes, it does. That's what data types are for. Data types basically tell the compiler, okay, so an int data type would maybe give me 4 bytes to work with, maybe give me precious 4 to 5. I'm not really sure on this one. This one probably like 8, this one 1, and this one 1, right? So different compilers and different computers take different memory for these specific data types, but usually these are the numbers right here, usually. But basically, data types tell the compiler, okay, allocate or reserve this much memory in the, reserve this much memory in the program for this variable, right? Now, the way this even works in general would be, now bear with my drawing here, maybe something like this. Okay, just imagine there's like lines over here making it look good. Um, so let's say you have, again, int apple, right? This address would be maybe 2, let's make it 201. I like this number a lot for some reason. 201, you have 4 bytes, right? 4 bytes of memory. So you're telling the computer, okay, reserve at 201, reserve this spot for a variable called apple, right? Now, let's say you do give the compiler, or you do give the you give your code, or you do give your variable value. Let's say you have 6 apples. You just wanted to play around your apples, and you find maybe 6 apples, and you're drawing a jar, right? Maybe apple equals 6, right? That's the easy way of making sure your apple variable is equal to 6. Now, what the compiler does is it makes it looks at the lookup table. I did not mention this yet, but as a compiler, it does not only allocate the memory, it also makes a lookup. It also adds the variable apple into something called a lookup table, which has the variables, information like where the address is at. Let's say it has. I'm not really sure. I'm pretty sure it's not how it's stored, but I'm pretty sure it's not the order it's stored in. But it's close enough. Maybe it has like the name, the address, and of course, let's just say the values here because I'm running out of space. Okay, so right here it goes like, oh, okay, well, none for now because remember we didn't make a very value for it yet. So it goes like, oh, okay, so it wants me to change the address, the variable address 201 into it wants me to change it into 6, right? So it makes this equal to 6. Let me draw it in a different color so it can make it a little more colorful and then all green. So yeah, so it just makes this equal to 6. Now, what if you want to know apple what if you want to know what if want what if you want to get their apple's address, right? What if you want to get uh, um, apple's address? Now, this is very easy to do. All you have to do is use the ampersand or address of operator, which is this symbol right here. Now, the address of operator simply gets the variable to its right address. Let's say next to the address of operator you have apple, right? The variable we are just talking about, address of apple. And then you wanted to print this on the screen. You would simply actually take a guess. What would you get here? If you guessed 201, you would be correct. Remember, address of or ampersand gets you the address of the variable. In our case, the address of apple is 201. Okay, so what if can you actually get can you actually hold, let's say I want the address, whatever the address of apple is, I want to store it, right? What if I want to store this variable? What if I want to store the address of this variable? Let's just say I wanted to store the address of apple. I want to store, what if store address of apple, right? Now you might simply say, okay, just make a variable, maybe call it int address, or whatever you want to call it, doesn't really matter, and then make it equal to ampersand apple, right? It's that easy. Well, no, you can't really do that. The reason for that is, the int variable and int data type cannot store an address. It does not hold. It cannot store the address because it's in hexadecimal. Remember, addresses of variables come out as hexadecimals, right? How do we store it then? How do we store the pointer? How do we store the address? Well, that's where pointers come in handy, right? So pointers, the way you make a pointer is simply doing this, and or whatever the variable you're. Now you guys see, as before we just made int apple. We made it an int because we knew that Apple will hold an integer value. We knew that Apple will hold the value 6, and 6 is of course an integer, right? We knew it would hold an int, and 6 is an integer. Now, how do we actually use int for pointers? Do we use whatever we want for pointers? Well, half half, right? In our case, the variable we want to point to, or the variable we want to store the address of, is Apple, right? That was the whole plan. That was the whole idea of this whole video, I guess. So we want to store the value, the address of value Apple into a variable, right? Into a pointer. Well, the data type for a pointer depends on the value the value of the address of you're pointing to. So let's say in our case Apple. Would our pointer be an integer, a float, or any other data type? Well, it would be an integer actually, and there's a very good explanation for this. Well, variable Apple is equal to 6, an integer. So what you're pointing to, what your data type for your pointer is, depends on whatever your variable that you're pointing to is data type. In our case, it's an int Apple, so our variable will be of an int data type. If our variable Apple was maybe float Apple is equal to 3.2, maybe someone 8, 5.5 quarter of an apple, whatever, then we would of course have um, we would have to say float for our pointer instead of int. Now, the other reason, the other what do you call it? The other step to make a pointer is instead of just writing maybe int pointer, or I'll just abbreviate it for p from now on because that's what they usually use. Well, we have to do this. This is called I mean, it's called the symbol is an asterisk, but it's called it's just what tells the compiler this is a pointer and not a normal variable, and not a normal variable that the compiler may read it as. For example, int apple did not have this because it's a normal variable. When you want to make a pointer, it's you have to write an asterisk. So now that we made our variable, let's real quick. So int p, right? Now that we wrote this down, the semicolon didn't turn out as I wanted it to be because handwriting isn't the best. You would have to do p. Now you can store p is equal to the address of Apple. And now, if you want to run this or you want to print this, I just want to end line there so bad, but let's keep it like simple. This would actually write 6. Now, the reason this would write 6 is the following. A pointer, oh my bad, this would write 201. Yeah, that's my bad. It just writes the address of Apple. It does not write 6 or 201. Because let's go back to this real quick. The address of Apple is 201 as we're on the beginning, right? Now, what if instead of getting the address of the variable Apple, what if we want to go straight to the value? What if we want to make p store the value of the address of Apple? Right? What if we just want to, in other words, dereference Apple? Let's get to dereferencing. That's gonna be fun, right? So instead of writing something like pointer p and then p is equal to Apple, this. What if after doing this, right? So you made the pointer p equal to the address of Apple. How can we make it so that we access whatever value is whatever value p is pointing to, or whatever value is stored at the address p is pointing to. In our case, this would be 6, right? Let's make this a more colorful thing because it's looking really dull right now. Let me actually see. Yeah, this is looking, man. So I didn't take. Okay, yeah. So in our case, this would be a 6, right? So what if we want to access this variable, right? What if we want to access apple, whatever's the apple? The way you would do this is very simple. You would use the dereferencing operator, which is actually simply to bring back memories asterisk sign. Now this might confuse you, right? Because we use the asterisk sign to, declares pointer, and it also dereferences pointers. What's happening here? Well, it actually does do both. Like there is no trick to it. It does both. But it's where you use it that the compiler knows what it does. So basically, if you use it next to a data type, obviously the compiler will know, oh, this guy is just declaring a pointer. He's not dereferencing it, and it just makes sense for a compiler. Don't really worry about that part. Just know that it's used for both. So don't get confused on it. Well, the way this would look, again, we're still following up with this code, by the way. So like, don't I could let me write it quick read so you can see what's happening. So int p, we made declared the pointer, then we made the pointer, and as you guys may have noticed, I didn't use the asterisk sign right here. You don't use it when you don't use the asterisk sign when you're using the pointer, if that makes sense. When you're giving it a value, you don't really use it, right? So p is equal to the address of apple. I did I rate it like was cursive right here though. It's nice. So apple, and then what if I want to print again? We said if we print this, we would get the guess real quick 201 or the address of apple simply. How can we get the value that is stored at the address of apple? In other words, how can we get the value of apple through a pointer? Well, that's really easy. All you do is just, instead of this, you write asterisk sign p. This would write, 6 in our case. This would write 201. So basically, we just went over the very basics of pointers. That's all it is. It's really not that hard once you really think about it. I don't know what just happened there. But yeah. So that is basically it. Yes, nothing more, nothing less. Let's just go over one more thing actually, right? So before getting into arrays and pointers, which I will most likely save for another video because this video is way too long right now, and people get bored of pointers, just want to go to sleep already. So before we end this video real quick, let me just talk about one more thing when it comes to pointers, which is going back to this right here, right? So just like I said earlier, right, we understanding pointers, we have to understand what data types are. Just like I mentioned before, data types are just simply specifying. Oh wow, I messed up this word. Actually, I didn't. Specifying what the value is. What the value type is. Maybe maybe integers. That kind of stuff. All the pointer really is just it's just telling the compiler that I will actually store edge address of something, right? That's all it is. Pointers are just value stores or storages. Pointers are just address storages. They are nothing more than address storages. They store the address of a variable. What you do with that address is up to you, right? You can, again, you can dereference that address, dereference, and you can do, many more stuff. Change up more stuff for the variable, etc. But we'll get into that later. For now, maybe you know already what dereferencing is, right? So that's pretty much it actually for variables for this video. And hopefully you guys learned something new. This is a very easy topic to get confused on. Hopefully I didn't confuse you further. I think I did, honestly. But yeah, leave a comment letting me know what you guys think, and I'll see you next time. Thank you guys so much for watching, and peace out.